All right, now, here we go. Now, what we're going to do is let's compute the normal force and the frictional force. That's the only thing we're going to do right now. All right, so that you can see what the normal force and the how to compute those, because those are the main thing that we use when we're doing this. So let's go ahead and click on my ladybug here. My own special lady. Is it, have you all didn't go to college in the 70s? Obviously, because you're going to college down to 20. I went to college. When I started college, it was in the late 70s, and they had the stupidest songs. The Pina Colada song. I don't know. Every once in a while, I still hear it, and I don't listen to oldies. I'm not one of those old farts who listens to oldies. I mean, I listen to my 70s jam on Spotify and stuff like that, but I don't listen to the oldies radio station because I can't stand the Pina Colada song. You know, my own lovely lady. Oh, I just want to smack the guy when he said that. Just go out there and just start wailing on him, steal on his ass. But anyway, so here we go. I'm in a mood. It's Friday afternoon, and the beer's getting warm. So let's get through this. Here we go. So I said, all right. Michaela hit some chunky snow here. So we're going to say the coefficient of kinetic friction is now 0.15. Notice it's just a number, and we know that the frictional force is equal to point 0.15 times the normal force. Well, what's the normal force equal? The normal force in this case is just equal to, let me just draw a quick picture of her on the snow here. All right, this is my quick and dirty Michaela Schifrin picture. All right, so she's got her center of gravity going down like this. The snow is pushing up on her like this. That's the normal force. Remember, though, the reaction force, though, to the mg, the reaction force is the center of the Earth being pulled up by her massive 65 kilograms. And the Earth is at 6.3 times 10 to the 6 kilograms, so she doesn't have much effect. So that's the normal force. So if I take the sum of the forces in the y direction, this is a really formal way of doing this, then Fn minus mg is equal to 0. So the normal force just equals mg. So I'll take the normal force is equal to mg, which is 60 times 9.8. One of your compadres asked, I had a student ask me, he said, where'd you get the 9.8? I said, I didn't come up with 9.8. Mother Nature did. That's the acceleration due to gravity. Okay, so we get 60 times 9.8. And Newton helped us figure it out. Cavendish helped too. 588 newtons. All right. So then the last thing, so let's figure out the frictional force. Then the kinetic frictional force, and we're just taking the magnitude of it, is equal to mg 0.15. I had a moment there, times 588 newtons, which equals 88.2 newtons. Now, let's talk about how, so there we computed the frictional force. Okay, now the next video we're going to talk about is how far did she go before she got to 5 meters per second? How much room does she need to go from 18 meters per second to 5 meters per second with this kind of punching in the gas? So let's figure that out in the next video.